All right. So the first part of our week one, module one content is going over basic Unix command line interface commands. And you might be thinking to yourself, I already know what Unix is. I've already know how to navigate file hierarchies, etc. And that may be true, but part of why you're learning everything you're learning is not only for your own benefit, but to the benefit of those you will work with and work for. So the more repetition you get in, the better. The more you know, the better you can explain and pass on that knowledge. And the more that knowledge is repeated, the more quickly you'll be able to recall it as opportunities arise. So yes, much of what we're going to be covering today might seem familiar, but keep an open mind and you might also find some new little tidbits of info here and there. All right. It's a Unix system. I know this. The immediate use cases of being a Unix whiz is speedy navigation. So being awesome when you're handling toil, for example, or being awesome when you're troubleshooting, especially in a live session, because knowing these commands at the back of your hand will allow you to quickly grab log files, know where to find key configurations, know, let's say even you're like working on, I don't know, updating a code base, implementing some new feature, troubleshooting some failure in the code after release, and you're in a staging environment or you're in a development environment, and you can either go the slow route of pushing your change to GitHub and waiting for the build and the deploy to happen before you could see the results, or you could be a cowboy and just start updating code on the fly in the node and resetting background services, checking statuses on these background services, SSHing onto the right node to do this stuff, navigating through the right directories, knowing which directories to navigate into, opening and editing files on the fly, updating this code, restarting the services, checking the logs, repeating this process for hours and hours until you've solved the problem you were facing. The more comfortable you are with Unix commands, the easier and faster all that will be for you. So it's crucial during things like production incidents where time is money. Knowing it better allows you to reduce potential mistakes, especially crucial ones that are irreversible, like running rm space dash rf. And knowing it better will help you be better at troubleshooting not only your own issues, but other people's issues. Let's say you are in a DevOps role, you may find yourself helping other teams. They're going to you with requests on how to do certain things. You're going to have to walk them through how to do that. You're going to have to know how to articulate it, not just in a way that you understand, but in a way that they understand. And, different people have different ways of understanding things. So the point of it all is practice makes perfect. What is Unix? We know we could think of Unix as maybe like having two divergences from Unix itself. We're going to have Unix-based operating systems, which are derived from the original Unix operating system, and they share some features and follow Unix principles. Mac OS is an example of that. And then we have Unix-like systems, which also share some design principles and features of the original Unix system, but not necessarily any proprietary code or specific implementations. This is going to be, we'll talk about this in a bit more detail in a sec, but this is important when it comes to knowing how to troubleshoot issues across different environments. Unix architecture itself can be thought of as having several layers. So at the very center, we have hardware, which is basically your human visible components. So everything you need to build a PC with, your CPU, your memory, your motherboard, etc. From there, we have a kernel, which is basically the bridge between the software and the hardware. It's what manages resources such as the processor, memory, the input and output, networking components, and it provides an interface for the software components to access the hardware resources. So you could think of the kernel in a way as being a gateway to all of the hardware. It's loaded up as soon as a PC is powered on, and it stays in memory until the PC is powered down. Next, we have the shell, which is what you'll primarily be interacting with. It's software that offers command line interface for user interaction. So it receives your user input, which it then interprets as instructions to execute. Examples include things like the original shell for Linux, or bash, which stands for Born Again Shell. The Windows PowerShell, which you probably won't be using too much because we want to work in a Unix environment. So you're going to be using, if you're using WSL, you'll probably still be using bash. Or if you prefer, other shell distributions like Zeesh. Zeesh is my personal favorite. We'll go over all of that in more detail during InstallFest. Application programs. These can range from command line interface applications to programs with GUI, general user interface, which you all should be very familiar with. And this layer really encompasses all sorts of processes that can vary in function and scale, from simple background services to executable scripts to full-on applications. That is your Unix architecture in a nutshell. Unix, as you already know, is a multi-user operating system. You can have multiple user accounts. Each user has their own set of directories in a home directory. And this is how they are able to separate things like configuration files, the paths where they install packages, personal files, shell files, things of that nature. The Unix file structure is pretty straightforward. It's pretty much like a very simple tree hierarchy. We have everything coming from a parent location. Everything inside of the file structure is either a folder, which can contain 0 or more things, or a file, which is like a leaf in our tree. And a folder can contain other folders, it can contain additional files, or a folder can be empty. And that's about the gist of the directory structure. We're going to go over some basic commands, which I'm sure you'll already know, but let's talk about them in a little more detail. So ls, this lists all the files in your present working directory, and you can pass in various flags, parameters, through flags, I should say, like all, to include hidden files. So when you type ls space -a, this allows us to see hidden files. You could string together different parameters or flags. In this case, LAH lets us use a long listing format. It tells us not to ignore hidden entries that are marked with a period, and it makes sure that the output is human readable. We then want to learn about PWD. This is super useful, and I'm not actually sure why these are in slides. I'm going to stop sharing, and I'm going to switch over to my terminal because it is a little more exciting to see this from a command line interface. So let me pull that up. And reshare my screen, if I could just find the right window. A lot of stuff open. Any questions so far while you all sit here and wait for me to go through all my windows?
Are slides available?
Ooh, good question. Typically in the past, they have not been made available, but that can change. I can make them available. I'll get you guys a folder, shared folder. You'll need a shared folder in Google Drive that I could drop all of these into. So I'm going to add that to my list. And yeah, slides will be available for the class.
Awesome, thanks.
Where, there it is. Okay. So let me. Okay, we're still recording. Now I just got to share my VS Code. Cool. All right. So we were talking about ls, which allows us to list everything in the current working directory. So here we see that we have a README and a directory. If we type things like pwd, which can stand either for present working directory or print working directory, whichever you prefer, whatever helps you remember it, this lists your current working path. Pop quiz. Who can tell me the difference between an absolute path and a relative path?
Relative path is based on where you currently are, and absolute is from the root.
Yes, exactly. So things like PWD will help you track where you currently are, because when you're navigating, you'll likely be using, well, you'll either be using a regular or absolute path, right? Here is an example of an absolute, or sorry, a relative path. It's basically saying I want to go up one directory. Give a better example if I knew, yeah, let's go back into this directory. And let's say I wanted to go into the other one. My relative path would be ... to show that I want to go up one directory. And then the other part of that path will be the folder I actually want to go into. And that is basic navigation. I should also add, for those of you that aren't as familiar with Unix and command line interfaces, CD stands for change directory. Very easy to remember. If you think of it like that, it's your basic form of navigation. If I wanted an absolute path, or pass in an absolute path, I should say, like so, your / denotes your root. This is going to take me straight to my root folder. And from here, I could see the files in my root drive. I could also go to this tilde, which basically takes me to my home folder. And if I list everything here, I see things like my documents. Keyboard shortcuts like Command K can quickly clear your screen. What else is in today's README that we got to cover? Let me now pull up another terminal. Or actually not a terminal. I'm going to pull up today's lesson in a browser instead, just so I could make sure I'm not missing anything. So we're going over this. We want to... Okay, so the last part of this is really just going over things like file manipulation, folder manipulation. If I want to create a file, somebody tell me what I would use.
Touch and then the name of the file you want to make.
Exactly. So file.txt is a file that I've created, and now we could see file.txt. How do I remove this file? Because I don't actually want it.
RM, remove file name.
Exactly. RM removes the file name. And oh, it's because I named it file. So clear that. Let's fix that. And now my file is gone. All right. If I wanted to make a directory, that's pretty simple. mkdir makes a directory. I could then cd into that directory. Let's see. we have, well, we would have to make a file first. So I'm going to make another file, touch file2.txt. I could copy this file using CP for copy. And if I wanted to move it up a directory, I could, before the new file name, add a different file path. So let me make another directory just to make this a little easier to see. I've made a new folder called folder2. I am now using move or copy. I was doing copy to move this, copy this file into folder2. So I now say file2.txt. Whoops. Let's just do that. It doesn't like that either.
It's you named it folder 2.
Thanks. Okay. See, what happened here was I did not start with a period. So this is reading it as an absolute path. It doesn't find a folder2 in my root directory, but the folder2 exists here. So I had to begin with period. A period will denote your current working directory, and the double period means one directory up. I can also use a file path to see what's inside this directory. And I could also use the path to delete this file. And so if we look in this directory again, I might have to pass in a flag for this. Nope, it doesn't like that. Oh, because I didn't pass in the folder, huh? So folder2. Now let's check that folder, and our file is gone. I may not have needed to use this, but basically -rf is a recursive function. It will remove anything that's also nested if I were to, for example, just pass in a path. All right, what else? That pretty much covers everything. The last thing in the in today's README is going over system linking, which I personally do not use that much, but basically a symlink allows you to create a shortcut. So if I were to say, I don't know, make a third folder. If I were to say ln for link and -s with a shortcut with folder3 as the directory name, and let's say F3 as my shortcut, I have now created a symlink for this directory. So if I now do a CD into that shortcut name, I am inside that directory. So it says F3. If I go into folder3, because that's the original folder, and create a file, let's go back out and go into our symlink and look inside. We see the file that we created in folder3 exists in F3 because F3 is really just a symlink of folder3. Does that make sense? Cool. All right, you have all made it to the end of the very basic introduction to Unix. Tomorrow, we are going to be going over a little more complex stuff. Let me switch screens again so we could just touch on that super quick. I'm also going to work on getting tomorrow's challenges up tonight because they're not up yet. But tomorrow's challenge will have us going over more commands. As well as user groups, permissions, and package managers. And of course, looks like I've got to clean this up a bit. Day 3 is going to be bash scripting. Again, so sorry that it's not available yet. And then day 4 with Chandra, you guys are going to be doing some SSHing. And that's it for the first week. From then on, we're going to be going over a lot of material that will be familiar to all you Whiskey students. So again, that's going to be prime time for you to focus on your personal projects. And for everybody else that's new, we'll just dive into the material as it comes along. Now we are going to have Install Fest. Since only a few of you need to run through this, I am going to open up breakout rooms. So if you've already done this, if your system is good to go, just join one of the breakout rooms, get to know one another, work on what you need to work on. And if you need to run through the Install Fest, stay in the main room. Sound good? Cool. Let me cut this recording and we'll kick